Hello, in this video I'm going to demonstrate how to do a two-column proof. This is just going to be an intro to proof video, then I'm going to make another video on using a two-column proof to prove triangles are congruent. So we have properties, postulates, and theorems that help us prove line segments or angles or different properties for given information, and we just infer from there. So a proof is just a justification of steps. When you're solving an equation, for example, that's a justification of steps. So if I know, if I have x plus 3 equals 4 and I want to solve for x, generally you would say, okay, I'll subtract 3 on both sides. But the reason is, why can I do that? Well, I can do that because I know this is true. I have a subtraction property that says if I subtract equal quantities on both sides, the equation maintains its integrity. So then that's how I find out x equals 1. So here's our first example. Prove PQ equals RS given that RP equals QS. So the first thing I suggest is that you make markings on the picture that you're given. So I know PR and QS are congruent. And I want to prove that in the end that PQ and RS are equal to each other. I want to prove that those things are the same. All right, so first thing is you're going to say step 1. You're going to write down your given information that PR equals QS. And our reason is because that was given information. So now we're just going to start breaking down this information we have. Well, PR, what is PR equal to? PR is made up of line segment PQ and QR. So I know that line segment PQ plus line segment QR equals line segment PR. And I also know that line segment QS is made up of segments QR and RS. So I know QR plus RS equals line segment QS. All right. That is by segment addition, the segment addition postulate. All right. This is in the orange notes paper you got in class. All right, step number 3. From the beginning, it told me that PR and QS were equivalent. So now I can just take these portions right here and set them equal to each other. So I can say PQ plus QR, because that's equal to PR, is equal to QR plus RS. This is done by substitution. All right. So in the end, I want to prove that PQ is equal to RS. So we're almost there. Look, we have PQ and RS on opposite sides of the equal sign. The only things we have a QR there. So how can we get rid of it? We need to cancel that QR out. Well, we can do that by subtracting QR on both sides of our equation. And remember, we can do that by the subtraction property. So in the end, I can say that PQ equals RS by the subtraction property. Okay. Here's your next example. Given the angle XWY, so this angle here is congruent to angle XYW, this angle here. Prove the angle AWX. So we want to end up proving that this angle is congruent to BYX, which is this angle. All right, step number 1, always write down your given information. So I know angle XWY is congruent to angle XYW by given information. All right, here's our next example. Line segment GH is congruent to line segment IJ, and line segment IJ is congruent to line segment KL. Prove that GH is congruent to KL. Okay, our pictures aren't drawn to scale, but we're just going to use the information we've been given. So, first things first. I know that GH line segment is congruent to line segment IJ, and I know that line segment IJ is congruent to line segment KL. That's given information. So the next thing I know, and I'm just going to say this explicitly, that means GH equals IJ. Their measurements are equal, and I know that IJ equals KL. All right, that's the definition of congruent segments. So I know these are equal to each other. So if GH equals IJ and IJ equals KL, then I can say that GH equals KL. That's by the transitive property. All right. So the transitive property basically says if A equals B and B equals C, then A equals C. All right. So I know that these two segments are equal to each other by the transitive property. So in the end, I know that line segment GH is congruent to line segment KL by the definition of congruent segment.